What is the mean of my electrical resistivity? So electrical resistivity is referred to the opposition, right? Opposition of current flow, right? So when the current I flow in the circuit, the opposition of the system is referred to the electrical resistivity. And number 2, calculate the resistance of iron wire, right? The uniform diameter 0.8 millimeter and the length 3.0 meter. So this is the L and this is the diameter D. So to calculate the resistance of the uniform wire, so we have a equation resistance of the wire is given by the resistivity rho times L divided by area A. Now the value of the rho is given by the equation is a 10.2 exponent minus 8 ohm meter, and the length L is equal to 3 meter. On the area A, because the question gives you the value of diameter, so you can find the cross-sectional area A by the equation pi diameter square divided by 4, right? This is for the area A. So now the final answer, the R is equal to 0.61 ohm. And question number B, a battery of EMF E and internal resistor R is connected across a variable resistor. When the resistor 21 ohms, the current, when the R is 21 ohm and the current flow 0.48 ampere. When you sit at 36 ohm, the current is 0.3. So now you have the two value of the current and the two value of the current flow. So number 1 is the calculate the what is EMF and internal resistance. So if you look at the equation, EMF is equal to current flow, external resistor R and internal resistor R. This is the internal resistor, this is external resistor. So the first situation, the resistor is 21. So now you have the I is of 0.48. Let's say this is E. I is 0.48, and this is for the resistor 36, and we have a unknown resistor, internal resistor R. Let's say this is a first equation, and the second equation we still use the same battery or the same EMF, but the second situation the current is 0.3, and the external resistor is 36. Sorry, this external resistor for the first situation is 21, right? 21, not 36, right? This is 21, and the second situation is 36, and we have the same battery, meaning the same internal resistor R. So this is second situation. So from the first and second equation, so you can use first or second equation, so the equation 1 minus equation 2, or you can find the value of the let's say the simultaneous equation to find the value of the E and the value of R, and the value of the E or EMF E is equal to 12 volt, and the internal resistor is a 4 ohm, right? And our next question, number 2, is sorry, we have another question, right? So number 2 here. So number 2, the power consumed in the internal resistor. Because the internal resistor R is 4 ohm, this is the value of R, internal resistor. So to calculate the power consumed is equation P is current flow in the internal resistor square time magnitude of internal resistor R. So now the value of the I current flow the internal resistor is this is the question as sorry, the current here is a 0.5 ampere, and the value of the internal resistor from the answer number 1 is 4 ohm. So meaning you can find the value of the power is a 1 watt. Question number 2, define potential difference and electromotive force. Most of the item here is the same unit volt, and electromotive force is unit volt. But the definition of potential difference, you can refer to the watt done to bring charge from infinity to the at a certain point. Let's say the point, this is the charge Q. Let's say this is a point charge. Okay, so moving charge, positive charge from A to point B, right? So this is at the point A you have a potential, let's say VA, and the potential point B at VB. So now the magnitude of the charge Q time potential difference A and B. But the electromotive force is referred to the energy provided by the source. Energy provided by the source is referred to the battery or cell or tri-cell, right? To each unit charge, let's say the unit charge Q flow in the system. But because of this is word W and this is energy, so meaning we have referred to the let's say the same process. That's why the unit of the V for the potential difference and also V for electromotive force, right? EMF, right? And the question number B, state the second Kirchhoff law. So as you know, the second Kirchhoff law is a total EMF is equal to total drop voltage, is IR. Or second Kirchhoff law state that in any closed loop, the algebraic sum of EMF is equal to the algebraic sum of the product of drop voltage IR. Right? So this is here is a EMF battery, and this is a drop voltage, right? So this is the first Kirchhoff law, and the second question is number 2. Calculate the current through the 12. Okay, here. So meaning the what is the I1 here, right? Using the Kirchhoff law. So as you know, you have 2 Kirchhoff law. But first Kirchhoff law, we have total I in is equal to total out. If you look at the diagram here, I in or current in, you can refer to the I1. This is I1, and now we have a junction, so divide to the I2 and I3. So we need the I1 or I in, and the I out is I2 plus I3. I2 plus I3. So this is first equation. And the second equation, you can first withdraw the loop, start from, let's say, start here. This is the first loop. Let's say I draw the loop, the second loop here, right? So this is direction of the loop. So now from the first, let's say this is first loop, and this is the second loop. So now the first loop start from the battery. This is 9 volt. Okay, before that, The definition of the second Kirchhoff law is total EMF is equal to total drop voltage IR. So meaning start from the first loop, we have a EMF here is 9 volt. We have only one battery here, so meaning it's equal to drop voltage. So start from here. So now the loop is continue, and we have I2 here. So direction of the I2 and the loop is the same direction, and now we have a drop voltage here at the resistor 18 ohm, meaning this is the current flow at the 18 ohm is I2. Drop voltage times R, resistance is 18 ohm, and continue junction, and this is direction of the I3 here is not the direction, this is a direction here is upward. So now the direction of the I3 and the loop is opposite direction, so you must have a negative sign. So this is direction of the loop and direction of I3 to upward, so I negative, right? I3 times 8 ohm, and finish. So this is question number 2, right? Number 1, number 2, and the third equation is come from the question second loop. So start from the battery here. So we have the 6 volt is equal to, so continue loop. So we have a I1 direction loop and the I1 the same direction. So now we have drop voltage here. So this is I1 time resistor is a 12 volt, continue. So we have the I2 here and we have another resistor. Now we have a drop voltage here. Now the current is the I2, but the current I2 is the same direction to the loop, so you must have a positive I2 times 18 ohm, and continue loop and finish. So this is equation 3. So now you have first equation, second equation, and the third equation. So now you can find the value of the I1, or you can calculate or find the value of I1, I2, or I3, because you have a 3 equation. Okay, you can use a Martinez equation, or you can use equation 1 into the equation 2, or 2 or 3, or 3 and 2, or 2 all in 1. So this is mathematics process. Actually, you can do your own calculation. I just give you the final answer, that the I1, the I2, and the value of the I3. Right? So the I1 is equal to minus 0.013, and the I2 is 0.342, and the I3 is a minus 0.355. As you can see here, you have a negative value, right? Negative value for I1 and the I2. So if you look at the direction of the I1 to downward, if you have the negative value, meaning the direction of the I2 is wrong direction, but the I2 must opposite direction to upward. The same process for the I3 direction to the right. So this is the wrong direction. I3 is to the right, not to the left, to the right. And if you look at the question asks you to calculate the current through the 2 ohm resistor, meaning the I1. So this is the final answer for question number B2. Thank you.